All right, welcome to today's virtual conference, Fast and Accurate Asset Inspections, Leveraging AI. I'm Lucian Fogoros, I'm the co-founder of IoT World, and on behalf of our team, our sponsor, Hitachi Vantara, thanks for joining us. There's roughly about 550 people from about 80 countries. And with that, I'd like to introduce our moderator for today, Scott McKenzie. Scott, the floor is yours.
Hey, thank you, Lucian. Appreciate that. And welcome, everyone. This is a topic that is absolutely near and dear to my heart. As an old crotchety transmission lineman with Southern California Edison, a big part of my work, my job, was in maintenance, big time, in making sure that the lines are safe and up and everything that is associated with managing those lines and substations. Anyway. So when we look at this particular technology that is going to be brought to you by both Brett Toplin with Hitachi Energy, as well as Shamik Mehta with Hitachi Vantara, I think they've got a real game-changing solution to truly manage these assets that, quite frankly, you can't see them moving, but they still have a tremendous amount of force and tension on it. You just need a better way. And especially in today's market, we've got that necessity to be able to do things in a more efficient way. And I think what we're talking about, how we're leveraging AI, I think it's a great doggone conversation. Before we get into the presentation, I want to lay some ground rules. And it's very simple. The best way that we learn and we grow and we achieve what we need to achieve is through a collaboration. And that means you got to ask questions, pepper this panel in questions that you have. There's no right or wrong answers. It's all important. And you got to lay it out there and ask that question. You can do it yourself or I can do it. It doesn't really matter, but ask the questions. Get the most out of this opportunity is vital for you, for everybody to be able to at least benefit from this game-changing AI solution. All right, with that said, I'll hand it over to the panel. Let's get going with the presentation, and then we're gonna have some Q&A after the fact. So let's get a cracking.
Excellent. Hi, everybody. I am Shamik Mehta. I am Director of Industry Solutions Marketing at Hitachi Vantara. I'm based out of California in the Bay Area. Working from home like most of us these days, but hoping to get back in the office one of these days and start mingling with colleagues like Brett and others. Happy to meet you all. This conversation is meant to be a conversation and less of a presentation if you want. So by all means, feel free to chime in at any time and ask questions as we go along. It doesn't have to be very formal. But we are really here to talk about how there have been advances in machine vision, and when it comes to understanding or leveraging AI to help with asset inspections. So the reason we got into this was essentially to help with the infrastructure challenges that transmission and distribution line operators and utilities are facing, mainly in the United States, but really all over the world, because infrastructure is getting old. Many of these assets have been in the standing for 50, 60 years. It's getting expensive to maintain and upgrade them. And there have been, in the United States, there were recent forest fires that have been in the news all over the world, I bet. And it's not just a North America thing. Australia has faced many wildlife fires as well because of transmission or distribution poles falling over and causing brush fires. It's deadly. People die. It causes billions of dollars in damages. Utilities go bankrupt. It happened in many states over here as well. And that's created a problem and a need for having better inspection methodology and understanding and realizing that utility assets are going to need near constant monitoring. There are tens of thousands of millions of miles of transmission and distribution lines around any given country. And in there, assets are at various stages of degradation. The climate change and other environmental conditions are causing them to degrade at different times and different locations, often in the same area or in the same state. Exposure to the wind and rain elements, moisture, temperatures, all changes that. And it's difficult for everybody to come up and pick the right maintenance strategy or the right upgrade or the right infrastructure upgrade plan all over their territory. So what's happening today is that the transmission lines, if you just talk about transmission lines, which are often in rural areas or in forested areas or near vegetation more often than distribution lines, if they fail, or if there's a spark and there's vegetation nearby, those fires are very difficult to predict and prevent. So to constantly keep going out and keep updating them to check for any defects or check for degradation is a manual process today. It's done with very expensive means. It's done through people hanging out of helicopters and taking photographs, or ground crews going and taking photographs from the bottom up, or people climbing and walking on those cables, as you can see there on the third picture from the left. And I think this is what you were talking about, Scott. I think this is part of the history that you had. You can probably talk about these problems than any one of us over here as a panelist. Can you, let me ask you a question, Scott. How did you manage this in your past? You're on mute. You're on mute, Scott.
Sorry, I muted myself because I was breathing heavy. Sorry about that. However, to your point, yes, I worked in South Central LA with Southern California Edison, primarily in the world of transmission, did a lot of distribution work just because we had a lot of underbuild and all of the joint pull type of construction that existed out there. And quite frankly, the way we managed and maintained our assets is that you had a patrol crew, and that patrol crew would just go and find a single line map and you would just patrol it. And the way you would do it with your eyeballs. And if there was something of somewhat questionable looking, we would climb the tower. We wouldn't de-energize. We would just sort of look at it, assess the situation, mark it on the single line map. I mean, you know, physically mark it on the single line map. We might take a picture, but the cameras at that time were pretty lousy relative to what they have today. And move on, because you had thousands of miles of lines and just a ton of stuff. And then sometimes it's just virtually impossible to get to, you know, it just, so there's just, it was very manual and costly. And so you would always have the conversation around, do we spend this maintenance dollar? Can we sweat this at, you know, you just sort of always managing that according to your financials. So to Shamik's point of view, did that, been there, done that. And yeah, it's just, it was very, very manual and very labor intensive.
Yeah, I feel your pain.
Yeah.
Well, you know, what we've done at Hitachi here, Brett and I, and our companies, what we've been working on is a way to figure out a better way to do this analysis. So, you know, essentially, if a utility or a transmission line operator or an O&M company shares with us the photographs that they have of their assets on the towers, we can automate the image inferencing. So we can tell a good product from a bad product or a failing product, assign a risk score, mark it on a map, and guide people by sending alerts through field service automation applications so that they know exactly what the danger is, where, and do it much, much faster than human beings can. And
let me ask, I was just going to say, this is interesting because you need to have a sort of a program to be able to capture those images. And you can see there's a survey up there for everybody. This is important. If you don't have the pictures, it's hard to be able to assess, do you have a drone inspection program? Yes, no, it'd be great to know what your feedback is on this.
Yeah. And, you know, if most utilities have some program to collect these images. So even if it is not a drone, it would be helpful to know whether they have a program to collect images and analyze them, period. And then if you did it with a drone, increasingly so, especially now that many utilities have gotten the FAA clearance to fly non-line of sight drones, which means that they can fly longer than the line of sight, which means that they're often on a flight path, pre-recorded flight path that can go and collect these images. They can take a photograph as they approach a transmission tower, both before and after, without having to turn around because they've got cameras facing in both directions. And that allows them, a drone, to capture thousands of images per flight and can catch so much information back that often what we found in talking to our various customers is they had the images already, whether they collected it through an old means of having someone like a Scott climb a tower or take it out of a helicopter or from ground-based photography, they have the images. It's the, how do you analyze tens of thousands of images fast enough without wasting the time of data scientists too early in the process? That's the problem that we are solving. More accurate inspection. We all know that AI often works a lot better sometimes than human beings. Of course, if a human being can get to every image, they might be able to do a better job. But when you have tens of thousands of images to get to, you can't. And that slows everything down. So our solution just does this for tens of thousands of images in seconds, and then identifies when it thinks that it's found a defect, but it needs a human to verify it, it flags it. So it will not just make a decision on its own and send an alert to a field crew member to say, go out and check this tower out in this forest here. It will ask a human being to verify that. We call that human in the loop. So it will do a few things for you. It's got a workflow to automate this entire process, streamline it, and scale the image pre-processing. So it does the image pre-processing, finds a high quality defect detection, narrows it down to the most biggest problem areas. If it is not sure, or if the model needs to be retrained, it'll ask a human being for help. It'll flag it. Once it flags it, and a human being steps in and says, I know about this discoloration type in this porcelain insulator type, ignore it. The model begins to learn. So the next time it finds discolorations of that sort, it will not continue to flag it to human beings. It will also tag the image. It'll indicate what kind of an asset it was, so it knows what asset it is. So on the one picture on the right, as an example, it knows that it's looking at the pins on top versus the insulators themselves. It identifies them. And then it will, on a map, show you where the tower is located, integrates with whatever the customer's field service workflow conditions already are, programs already are in place. It integrates with that through common APIs and sends an alert. Of course, it is highly secure. These assets are utility assets, owned assets, so they are sensitive images. They have to be kept secure. So the process that we uses, of course, all the latest and modern IAM and reporting techniques and everything else to make it really useful. Essentially, why we're doing that was because we were talking to customers and we found out that it was just very costly. One customer was using 2 skilled full-time employees who was looking at 5,000 images manually a month, 2 people. And another utility that we were talking to in North America was using up to 80,000 images a day. So they needed to scale to that level, 80,000 images in one day. That was just taking so long that the inspections were getting delayed. That's putting everybody at risk, including the assets themselves. And they were also spending very high risk and expensive methods with telescopic vision or from the ground or from helicopters. And it was taking them at least 2 weeks to get the critical asset health data back. And then, of course, there's human subjectivity. So the AI-based inspections just avoids all those by streamlining the processes. It automates those manual tasks, reduces downtime, and of course, reduces safety as well as lowering O&M costs and risks. How does it work? If anybody has any questions about that, it's simple. We just gather the images from any source. We at Hitachi are not really in the business of operating or selling or making or flying drones or helicopters. But if the images are available to us, and most people do already have the images, it's what we can do with the images and how fast and how accurately. That's what we provide. So we ingest the raw asset images or videos. We can literally pause a video stream and get a snapshot out of it. And then the image-based processing engine takes over. It does the image ingestion, reprocesses them. It does the analysis on it, and that's where the Brett's magic takes over. It will select a human being if necessary, and then it'll find the asset condition. And on a dashboard, it'll tell you the location, the defect type, the severity, when it was collected, etc. And then processed images with those identified boxes that you see on the bottom right are meant to alert the field crews on the location and send dashboards or reports out to management. Next, I just have a few samples about how the model has picked up a defect type. It found a damper and it said, this damper is bent, and it gave a code and assigned that DMBE for a damper bent code. And the software will flag that. It finds some pins and insulators, and it finds the hooks and the clamps around it. It can find, for example, this porcelain insulator is broken right over here, and it assigns a code saying porcelain insulator broken or PIBR. It finds a contamination on a porcelain insulator. It can find the contamination. That could be a sign of arcing that could have happened. It can identify when a cap is normal versus a cap that is rusted. That can be a potential for damage sometime in the future. So it can identify all of these. These are the processed images, and it'll send the alerts out telling you where these are located. In other words, it found some images, raw images, and then it found the caps and the clamps around it. It finds if they are bent or not. It finds rust on it. It finds for arcing on the porcelain insulators. It finds for any broken pieces of the insulator, etc., and does it thousands of images at a time. With that, I'm sure people have questions about how this actually works internally and the innards. And I'm the marketing person, and I do not go into that territory. I do not venture there, and you can thank me for it later. But Scott, unless you want something to say once you get off mute, I'm going to ask if Brett, my colleague here, can introduce himself as well as tell us how the magic works.
Yeah, we've got a question out there, and I think it's a good question by Mike Laurie. Who owns all the images with their associated confirmations? Who owns them?
The utility does.
Okay, is that database of associated image available outside of Hitachi?
We, with permission, if they have the same permissions from the same utility for us to share the images with them, then yes. But no, we do not own the images, and the permissions has to come from the utility that owns them.
Mike, thank you very much for the question. I hope that answers. By the way, I'm looking at this insulator to the right as I look here. You see that hook that's up on the top there? That insulator needs to be replaced. There is no way that an insulator with a hook like that would ever, it's just not the right construction. Just FYI, I have never seen that before. I would never have that.
Thank you for that insight. Brett, over to you. Why don't you tell us a little bit about what you do and how computers sometimes are better than people like you and me?
Yeah, thanks, Shamik. Hi, everyone. My name is Brett. I am a global product manager of what we call energy market intelligence at Hitachi Energy. So I have a lot of focus on energy market data, using that data through fundamental models to do forecasts and actually putting it into optimization engines to simulate the market as well. And then I also work on our machine learning platform to enable different groups to leverage machine learning without having to know all the statistics and programming behind it. And I work out of our Colorado office. So to take a step back, like Shamik was mentioning, if we want to look at how computers analyze images, it's not too different from how a human would. But when you think about it, because we've been doing it for so long, it's actually a very simplified process, and it kind of takes you back to when you're learning about things. I'll have a little anecdote on that. But so images are just data. And machine learning works really well with large amounts of highly complex data and finding relationships within that data. If you think about an image, it's basically just a collection of pixels. And so what machine learning algorithms or computers will do is they'll basically break a picture down into this very finite, detailed piece of a pixel. And the algorithms will actually look at the attributes of those pixels. So I have a few examples here. They'll look at things like borders, color changes, textures within an image between those pixels, and looking at the relationship between those pixels. And then it's actually a very simplified process of overlaying. You could think of them as like filters, overlaying these to put those pieces together to make a more complex image. So there's an example of you could take a nose and an eye and maybe an ear, and we as humans know that that's a face. Computers can be trained to do that same thing. But the key component of that, and this is where I think the human interaction is so valuable, is it's the training aspect. Computers can learn and train on anything. It really benefits from having that domain expertise to train them up. And, I have a toddler, and there was a phase where he thought every single thing outside was grass. So you continue to train and learn, and then identify trees and bushes and grass. And it's not too different for an actual computer or an algorithm working on this. So I mentioned it's a little different than the human side. A lot of that is because as humans, we've been doing this subconsciously for decades. While computers can learn much faster, they do still have to go through that learning process. Some of the challenges are computers only know what they've been trained to know. So there is a manual aspect. There is this idea of gaining enough imagery or enough of those pictures, like Shamik mentioned, so that that computer can continue to learn, or the algorithm can continue to learn. And they need that imagery. If you think about our experience, we've probably seen billions of what you would consider images, snapshots of looking around. It's not that different. The more imagery that an algorithm sees, the better it will perform. And then a very, very interesting aspect to that is perspective. And this is where I think that image pre-processing that Shamik mentioned is so valuable. Is for us as humans, you can look at a dog from maybe the side from 30 meters away, and we've seen it enough times that we know it's a dog. But that projection or that perspective is something that's always new to an algorithm that's doing this. So flipping, rotation of images, hidden portions, those are all things that need to be accounted for in this process. Now, the benefits of it, which I think vastly outweigh the challenges, are that computers can learn and relearn. I think you heard Scott and Shamik mention that you typically would have somebody who's well trained in the industry doing this manual research. A computer doesn't need to be trained. It can learn about insulators one day. It can learn about downed lines the next day. It can learn and relearn, and they learn so quickly that if you have enough information to train them, it can be applied in infinitely different ways. And they continue to get better and better. Not to say that humans don't, but computers really will continue to improve.
So Brett, this brings to mind how this can be used or is being used in other parts of the businesses and other verticals as well. Because I remember back when self-driving cars were still being researched, 10 years ago, one of the biggest challenges that the car's algorithms had was understanding a small object that is rolling towards the curb. Whether it's a carry-on suitcase that has walked away from somebody and is rolling to it, or whether it's a small child that is approaching the curb. And the way that the car has to react to both is different. It cannot react the same way. But even teaching a car to understand whether one is an object that is rolling over, like a shopping cart, versus an actual small human being that is coming towards it in that same pixel or that same rectangle, it was not easy. But I'm sure that you must have seen this applied to other use cases as well, right? Beyond transmission lines and insulators. You have any examples of that? Other application that you can talk to, perhaps like the ones here?
Yeah. So these are a few really interesting examples, and one that I've done myself even. The autonomous vehicles is a very interesting one, like you mentioned. So this, I actually heard that a lot of Tesla vehicles will every mile collect data on what they've seen and feed it back. So they're continuously improving. But anything that you can visualize and put into an image can be analyzed. So it's got heavy application in radiology, where a number of researchers have claimed that there's essentially more accuracy from an algorithm in finding cancer than there is from a trained professional. I think that you always want human intervention in almost all cases, because you would never want the bedside manner of a computer versus the bedside manner of a doctor. But that type of application, it's also being used to measure climate change and deforestation. And then one that I've done myself was more on the marketing front of looking at Instagram. And so essentially analyzing images from different fast food companies and seeing what type of image gains more traction with its viewers. It might have more likes, may have more comments. And so understanding, is it a picture of food? Is it a certain color? Is it a different angle? That type of thing, which, you know, a lot of marketing organizations can then use to just engage with their users more as well.
Yeah. That those images are making me hungry.
Hey, can I chime in with a question or two?
Yeah.
If that's acceptable.
It is.
What comes to mind, because if there's a line and you have a crew working on a line and say, I got to de-energize this transmission line, does the system interact with their work management system so that you could be more efficient when that line is de-energized and there's some identification of the assets that need to be repaired? It might not be a part of the original capital project, but it's like, it's on the line, go, you know, it's de-energized. Can that be a part of this?
My understanding is not automatically yet, but what it will do is it will integrate with maintenance work order management systems, your enterprise asset management systems, or your asset performance management systems, and it integrates with the field service management systems automatically. So it'll send the information to the mobile app, and it'll tell you where the location is and what kind of asset it is. It cannot automatically de-energize anything. No.
It's already a part of a capital. It's being de-energized because they might be planting a pole or a tower, just work on the line.
Yes. So it does give you enough details about the asset and the conditions there that the field service maintenance workers know exactly what to expect.
Perfect. Another question. We've got some people that are participants that are asking questions. Can I chime in real quick with a couple of them? So
Sure.
we don't let them languish out there. Mike has some additional questions. Can we use your algorithm for identifying images? Can we use your algorithm for identifying images within point clouds? Hope I asked that properly.
Yes, we will engage with you in a services model so that you can leverage our algorithms as well. Correct.
And I'm terribly sorry if I mess up the name, but it's not out of disrespect. Nadai, I help. Please, as a PhD student, could we get some collaboration from you experts for our thesis work?
Good question. Why don't you reach out to me and let's take that one offline. We might be able to leverage your brains for something else also. You never know.
There you go. And then Seben, curious to know how many images this can process in a minute, hour, or day, etc.
Brett, any idea?
You know, I think that in my experience, I think it varies. You know, I think hundreds of thousands is not unrealistic. But it also can depend on, oh yeah, easily in that amount. But it really would depend. We're talking more in minutes. But it also depends on the complexity of the images and the complexity of the problem you're trying to solve as well, since it's looking at the relationships between those pixels.
This sort of jumps to the question I have. Let's just say historical images, because everybody has historical images, and they vary in quality versus to maybe images going forward, which it probably are higher quality, just because that's just how things work. Do you try to reconcile that? Do you take the historical and then can you do that? Can you go? How far back do you want to go? After a while,
isn't that pre-processing, Brett? Doesn't that take care of image quality issues?
It could in some degrees. It depends if it's like an issue with pixelation, pure visibility. And that is definitely an interesting aspect in really all machine learning problems is you want to use as much history as possible to define what you're going to expect in the future. But if what you see in the future really is unrelated to history, then it starts to become less useful. So it could be quality of images. It could be like what we're seeing in the generation mix now, where we're seeing more and more and more renewables that the more you try and predict on a fuel mix that's heavy coal dependency, it just becomes harder and harder to recreate what we've seen in the past. Right. And so sometimes using less can actually be easier for an algorithm to still learn.
Interesting. And I bet like if an image is not good enough quality, I bet the program just spits it out and says, this is not acceptable, correct?
Yeah, yeah. And you bring up a really good point that it's always going to try. For us, we're 9 out of 10 times we'll say, yeah, I'm 100% sure that's a dog. Maybe there's that one that's an off breed that you're not really sure. You might say 75. A computer will always spit out, we think this is something, and it'll give a confidence band. It might be 2%, it might be 95%, but that's another major benefit of it too, is as humans, we can set that cutoff within the algorithm and say, well, if it's not more than 75% confident, we don't want to hear about it.
Right. Interesting.
Okay, continue. Yeah.
No, we're done with slides. This is an open discussion.
Oh, well,
so
here we go.
For more questions from anybody.
Then I've got a question I want to pepper you with, and that is, there's a lot of weather conditions that impact utilities, Northeast, Southern, wherever it might be. And is there a way of being able to, through your machine learning, through your algorithms, through that solution, that you begin to pull in other locations to continue to refine the accuracy of your AI platform by using other utilities in that general location, as well as similar, let's say, insulators? Oh, utility A uses the same insulator as utility B, and we say, and you start to pull in all of that wonderful data. Can you do that?
Short answer, yes. Longer answer, we do not know if we can merge different utilities data sets together. I'm sure we can't. But as far as the algorithm is concerned, for us, it's just a data source. So weather data, map data, environmental data, or data from anemometers or weather buoys for wave heights, all those things are just input data streams. And you have enough data and you have enough ability to do the data preprocessing or the ETL or the data management and the correct storage and cataloging and tagging. Yeah, we can. I'm sure if Brett has access to a big enough data set, he can do pretty magical things with it. So short answer would be yes, but in longer term, I'm sure there are complications around mixing or merging assets from different companies and different owners. Even for us, by the way, when we are working today with on just insulators, we have to work with the utility who owns those models. So it's not a solution that you download from a website and unzip and install and you're ready to go. The images have to come from somewhere. We have to build the models and train them. Granted, it only takes days and weeks for us to do that, but the images have to come from somewhere. So we do have to build the model first. So it's not a slam dunk that we are ready to go on day one.
Yeah, but you've got a process to continue to hone, refine, and
yes,
and make because I would imagine the goal is to be able to elevate the probability of something to fail, and that you can then use your workforce to make the correction properly, right? Deploy that money in this area.
Absolutely. That's why we started off with 1 or 2 assets, right? We started off with insulators on transmission lines and all the structure that goes around with it. Or we've also worked on distribution poles where we can identify a bird's nest, or we can find a crack in the wood. And those are the things that, because those are some of the most severe, most commonly occurring defects, that's what we've trained our models for. So if a new utility wants to work with us, and those are actually the assets that they want identified, our models are ready for that on day one. But if it's, let's say, a transformer, and to figure out how old the transformer is by just taking an image of it, I gather that might take us a few days to create. That was my point.
All right, we got a question from Mike again. You talk about merging data sets for imagery. That's what he said. But can you use other data formats such as FLIR? I don't know what that is.
Yeah.
I would imagine having FLIR data would help tremendously.
Yes.
Can somebody explain what FLIR is first?
I think it's probably thermal images. I'm not sure. FLIR probably stands for that. Mike, you might be able to tell us that in the chat. But I think it's a different sort of image. So it could either be a thermal image or an IR image. And the IR and FLIR might be from that. Apologies if I do not know that. But
yes, heat imagery. Thank you, Mike.
Is that correct?
Yeah, Mike responded. Heat imagery, yes.
Heat imagery, yes. So the answer is yes, we can, and we do. So today we do have solutions that are that you can ingest taken photographs from IR or thermal-based cameras as well, or even LiDAR, and we can superimpose those and create using a visual analytics software. We can find anomalies in it. So today we use it for substation security, for example. So energy substations are often located in hard to get to places as well. And the security of those assets are important. And we have solutions that merges FLIR cameras, thermal radiometric cameras, as well as regular 4K cameras with edge gateways and sound detectors, as well as horns to scare off an animal, to be able to constantly monitor them, always panning, finding any dead spots, including pointing at some high voltage circuit breakers or transformers to check what the thermal imagery is, to check if this one is getting hotter, more faster than another one or others, and be able to, again, through the field service management integrations, be able to identify an authority when either somebody has encroached inside the territory, the periphery, or an animal has burrowed in, or if an asset is running too hot.
Well, the reality is, Shamik, you want as much information as you possibly can about that asset to be able to draw a conclusion of the overall health. Yes. And whatever that takes, IR, vibration, whatever you can get, it only helps with the determination of the health of that asset, correct?
Yeah, not only that, but we also make the entire suite of products, right? Not to sound too much like a marketing or salesperson, but we have asset performance management software, enterprise asset management software that automatically can find defects from many of these models that we've already built. So we already are identifying and prognostic and diagnosing what the probability or the likelihood is of something like that failing. So we've been doing that up to $4 trillion worth of assets already around the world. We have $4 trillion worth of energy and utility assets around the world, which we are monitoring today with our enterprise asset management or our APM solutions today. So when it comes to that, we are absolute leaders in that, and we can do that every day. Thank you, Brett.
Yeah, here's a question I don't have an answer to, and I just know how things work out in the field. There is this desire to sort of have your head in the ground, head in the sand. Do I want to identify that risk? Do I want to identify that problem? And it's discoverable, right? It just is. Do you have any pushback on companies that are saying, hey, I like it, but let's manage this information?
We do, but it's not we don't recognize the importance of it. It's often because we know that this is important to us, but we don't have the manpower to do it, or we can't hire people fast enough to do it, or that's not our core competency. So are there others that we can trust who's done this before, who we can get help from? So it often comes down to essentially credibility and experience, and them recognizing that they don't have the as many best easy to use tools that are available from the plethora of confusing options outside in the world that they have to choose from, to figure out how do you select the best way to establish that data management basics, to say, I need to be able to take in or consider FLIR inputs as well as video, as well as still images. Where do I store all this? This is a massive set of data. It's regulated. Do I need to keep access to it? Do I need to govern access to it? How do I clean it up to run analytics on it? Who do I share the results with? That's where people often ask us for that basic level of help as well, in addition to, of course, Brett's machine learning genius. So it varies. But no, it's usually not because customers have not recognized something. It's usually because they know the need, but they can't prioritize it high enough because of all the other challenges.
Yeah, it would seem to me that as we continue on this journey, whatever this, the utility 2.0, whatever this journey is, there is a necessity to be able to leverage solutions such as this and others to make work more efficient, to identify problems sooner or challenges sooner. And it's the only way we're going to be able to roll, as well as with that collaborative mindset. I would imagine that there is a necessity for others utilities to constantly talk, to be able to just ensure that our it's safe, it's available, and so on and so forth. And I think that that's key. A couple of questions. Don Ferrara, anyway, they have a similar application for oil and gas offshore industry for integrity of assets. It was just more of a statement as opposed to a question. Another application similar to vegetation management for transmission lines, same sort of approach. And he points out the Amazon forest in Brazil. Vegetation management is just a whole nother bird, right?
It is.
And when we start talking about where to deploy those maintenance dollars, how to trim, where to trim, why, what's the type of tree, growth rate, rain, sun, you have so many components associated with that to effectively and move forward with a maintenance
Absolutely.
approach.
Vegetation management is a big deal. It's done also very manually today, done through LiDAR-based trucks that roll around. It's a massive problem. I think the future for that is going to be satellite-based, personally.
Yeah, I agree with you 100% on that.
That's the way, because
we used to get into trouble for trimming trees in front of homes to get them out of the line. We weren't arborists. We were linemen trying to get the branches out of and we just demolish the trees.
Yeah, talk about a hack job.
It was a hack job. We didn't say, "Oh, is that a knuckle that we got?" No, we didn't do anything. Get it out of the line. In fact, you would trim it so short so that you would never have to come back because the maintenance wasn't there.
I like it.
You'd almost kill the doggone tree.
Right.
And we just drive off. Right. Here's Gary has a question. Can you easily access and extract an historical series of photos of an object to show the deterioration over time for budget presentations? Good question, Gary.
Hey, I would like to say yes, but that's because I have a different role than Brett. So let me ask him to chime in instead.
Yeah, and I can't speak for the system explicitly, but a lot of it comes down to data management, right? If you are using consistent methodology for naming the imagery files, assigning consistent IDs, assigning timestamps, that type of thing is really, really simple and can go a really long way, because then those images can be, one, extracted and used, but they can also be used as lagged variables to be input into the model. So there's benefits in, not having garbage in, garbage out, but there's benefits to having just clean and consistent labeling of the files as well. It might have been more about how the system treats it though. So I don't know if you want to add anything to that, Shamik.
No, I think that was perfect.
I think Gary's point is important, because every year they're talking budgets, man. Where do we put it? Where do we send the crew? What capital projects are we looking on? And why? And this and that. And because I see, me personally, maybe other people can chime in, workforce management is a real challenge, right?
Yeah.
Finding people, because once you identify a deteriorated asset of some sort that needs attention, you have a limited workforce to be able to say, okay, go out there, climb up, do what you need to do, and so on and so forth. And that is a whole nother conversation too. Vegetation management, workforce management, and all of the what you guys, but it chimes in, or it really speaks to the necessity for leveraging technology to do your work in a smarter and better way, right?
That's right. That's right. No, I think your viewers are asking the right questions, and they come to the right source. We've been doing this for a long time, and we are very large and dedicated to this space. We have a $10 billion a year business in just our energy verticals. So we can do this all. And as already mentioned, you do have $4 trillion worth of assets under management. And by some aspects, 1.8 billion people, with 25% of the world's population is being supplied with energy, which has some amount of Hitachi Ventura's products associated with it, a quarter of the world's population. So with that, if there are no more questions, I would like to say thank you to our viewers. Thank you to Lucian and you, Scott. And if anybody has any closing comments, please do them now.
All right, so we're in the Q&A again. Is that what we're talking about now?
No, I think we're probably done with all the questions, right? Unless there are more coming in which case I can stay on for a few minutes longer and answer. We are approaching at nearly an hour.
Well, Don would love to connect. I'm a former university professor, former technology director of Halliburton, and currently R&D director of an American AI company. Okay. I
Don, reach out to
mentor,
me.
So
Reach out to me on LinkedIn. I'm
there
Shamik
you
Mehta.
go.
There's a few
Reach
of
out,
us.
Don. Reach out to Shamik. How can, this is Mike, how can we get a hold of you guys offline?
LinkedIn.
LinkedIn. All right, Mike? Could you please share the recorded video? Is that Lucian?
That's Lucian.
That is correct. Within the next 48 hours, you receive the recording link.
All right, there you go. And then I may have missed, but will you share it? Okay, already. Barack, yes, gonna share it. Sophia says thanks. I don't know about you guys. I thought I think the conversation was, we just have to be smarter. We've got to leverage technology as we go along. We have workforce challenges. We've got aging assets. How do we deploy our maintenance dollars in the right way? And I'm all into that. Absolutely. This is interesting. This is Osama. How do you deal with no-fly zones near power lines? I've never.
Oh, wow. Luckily, we get involved once the images are already collected and when they need to be analyzed. So we don't operate the drones. I think that is something that the utilities would have handled because they own the assets. So as long as it's their own program and their own drone program, I'm sure they can get the right of way to do that. I
got to tell you, as a lineman, I would have been just really happy to be trained in drone pilotry. I mean, it's like that's like upskilling my skills to be able to pilot a drone. I'm telling you, I would have geeked out on that one.
Yes, Scott, it would have lasted maybe about 5 years because now they're all pre-programmed on flight paths.
See, you're right. You're right. That's an interesting one. And then Mike Laurie had one last comment here. What you just described as digital twin, I guess I want to go at it. Yes. Do you have the capabilities to provide this for existing assets?
Yes. So we are big time digital twin providers of everything from an entire grid, a digital twin of a grid, to individual assets like transformers or car engines or hydrothermal dam equipment. So yes, we do operate and create digital twins in various environments. Usually it depends upon the outcome that the customer wants. It's really the outcome-oriented digital twinning that we normally do on this. But yeah, short answer, yes.
Well, what I see is that for me personally, and this is sort of macro, is to try to find a trusted resource. You might not have maybe not have the solution, but you know who does that. And it's imperative that you find trusted people to collaborate.
Yeah, absolutely.
Don't,
yeah, everybody cannot be an expert on everything, right? Everybody cannot be an expert on everything. We are experts on many things, but not everything either. So we often always have to partner with somebody also quite regularly.
Well, I'm industrial talk, so I'm an expert in everything because I get to talk to everybody like you.
Yeah, well,
so I just keep on learning.
You're the expert.
It's it's brilliant. All right, that's pretty much wrapping up all the questions. But I just want to thank everybody, whoever's available out there. I thought the conversation was good. I think the technology is fantastic, and I think it's imperative that wherever you are in your journey in this, whatever that is within your space, I think there is a necessity to not shy away from innovation and just keep on moving forward, keep going down that journey. And it's important that take place to create a business that is both resilient and for the long haul. We have one more survey question. Would you like to get in touch with more details about the solution discussed today? Just answer it yes or no. Pretty easy peasy. And I think you're in good shape. This was a great conversation. Of course, I can geek out all day long on it, big time. So thank you very much for joining. And once again, do not hesitate to reach out to these two gents. You can trust them, and they got some good stuff.
Thank you for everything.
Thank you. We appreciate everyone's time.
Yeah, we do. Bye.